let's look at differentials when dealing with functions of several variables. If we just remember for a one-dimensional function, the idea of a differential for a line y equals f of x was formed when we look at tangent line to a point and rearrange the equation dy by dx equals f prime of x gives us dy equals f prime of x dx. The derivative relates the lengths dx and dy in this way. And the differentials obey the usual chain rule and so on for calculus. One can think of these as infinitesimal quantities, or in certain situations you can think of them as just finite quantities as well, provided this diagram is kept in mind. And in the limit dx and dy become infinitesimals, we can then look at dy by dx as a derivative of y. For functions of several variables, what we have is a slightly different rule. We have the total differential is dz, a small change in z given by a small change in x and a small change in y is dz is df by dx times dx plus df by dy. So one can think of this as an infinitesimal relationship with infinitesimal changes in dx and dy giving rise to a change in z, dz, or these can be small changes giving a small change in dz. One then can use this as a linear approximation near a point. Geometrically, let's have a go at drawing what this looks like. So we have a coordinate system somehow and a point on the surface. So we have the tangent plane at a point, z equals f of x and y, which is a plane that's tangent to the surface at some point. If this is a change dx and a change dy, the corresponding change in z is this distance in here, where we have a height above the xy plane. This line here has a slope, which is the partial derivative of f with respect to x. And along here we have a slope, which is the partial derivative with respect to y, which means then that this length in here is fx dx. The change in height in the y direction is fy dy, and so the overall change in z is fx dx plus fy dy. So if we go back to our example of changing coordinates from Cartesian to polar coordinates, if x is r cos theta and y is r sin theta, the differentials dx and dy can be calculated as dx is the derivative of x with respect to r, which is cos theta, times dr, plus the derivative of x with respect to theta times d theta. And for dy, so dz then is dz dx times dx, which is now cos theta dr minus r sin theta d theta, plus dz dy times dy, which is sin theta dr plus r cos theta d theta. If I now gather together the drs and the d thetas, this becomes a part with dr and a part with d theta, and we recognize those terms in brackets as the first one times dr is just dz by dr, and the second one is dz by d theta. So by using the chain rule, convert the differential dz from changes in dx dy to changes in dr d theta.